Okay, hello folks. Here's another one, a shortish video showing you how to conduct Factorial ANOVA using SPSS. This time it's an independent groups design, but it's a 2x3 Factorial ANOVA. So I've got two independent variables, one with 2 levels and one with 3. And unlike the previous video, in this particular piece of analysis will produce a significant interaction. So I'll show you, what I'm going to do here is show you a way to run this analysis so you can obtain the output for any simple effects tests you might need to do, and any post hoc tests as a result of significant simple effects tests. So pretty much I'm going to show you a short way with a little bit of typing to get all the output you will need to interpret the result of a factorial ANOVA where you might have a significant interaction of some sort. I think the main kind of trick, the main difficulty, running the analysis is quite straightforward. The main difficulty is the fact that you get quite a lot of output, so knowing which things to pick out of the many tables that SPSS gives you. But the data set I've got in front of me, it's made up data, but it's from the idea is it's from a behavioral economics study, and participants played in pairs. They played some sort of economic game where they had to decide simultaneously, how much of a resource they would like to consume, and they acquired points for their consumption decisions, but they were having to trade off really overusing the resource and destroying it and ending the game against taking smaller amounts which sustained the resource so the game could continue for more rounds, and by doing so, by behaving in a more restrained way, they could potentially accumulate more points over a longer period of time than if they just grabbed all the points available. Okay, so the resource that they were playing for is kind of a generalized resource. They just had to select how many units they would like to take in each round. But participants were subject to a couple of conditions. One of them is anonymity, so they played the game either in the same room as the person they were playing against, so a seen condition, or in separate rooms, so they never saw the other person face to face. And they also played in conditions where the amount of information they had about the resource differed. So one of the conditions was known value, so the value of the resource, how much of the resource was available, was known to the participants throughout the game, so they could use that to make their decisions about how much they'd like to take. Another condition with low uncertainty, where they didn't know the starting value of the resource, but they gained more information over rounds as the game went on. So as the resource depleted, they kind of were told how much was left, so they gradually acquired more information as the game was played. And a third one, which was a high uncertainty condition, where they never knew how much resource was available, and they were only told if it was depleting or if it refreshed after each round. They never told how much was available throughout the game. Okay, and the idea here is essentially a couple of things that could be tested. When people are making decisions about resources, if they have ambiguous information, they will they will be more cautious in their decisions and make smaller consumption decisions, or they will do the opposite and kind of just grab what they can and assume that there's lots of the resource available for whoever wants it. In terms of anonymity as well, there's kind of quite a lot of research that suggests that when people are interacting strategically around resources, if people are anonymous, so they never see who they're interacting with, they are more likely to behave in a kind of in a way that's more self-interested. So There's no reputational damage because no one saw them do it, so maybe they will take more than they should. Okay, so a couple of things that are potentially being looked at here, but what we're going to do is run this analysis. There are 48 participants. We're going to run this analysis and look at how two independent, categorical independent variables, anonymity, which has 2 levels, seen and unseen, and information, which has 3 levels, known value, low uncertainty, and high uncertainty, how they affect mean consumption decisions of participants, which is the DV. Okay, so we're going to run this slightly differently to what we've done previously. What we're going to do to start with is we're going to go to File, New, and then Syntax. And it'll bring up this syntax editor in SPSS, just like that. So this new pop-up box, maybe some of you will have seen this before, I'm sure, if you've used SPSS extensively, others maybe not. But we're not going to do anything with it at the moment. We're just going to leave it like that and then click on our data set again. And all we're going to do is set up the analysis like we would normally use in SPSS. Okay, so it's a Factorial ANOVA. So we're going to go Analyze, General Linear Model, Univariate, gives us this usual pop-up box. And remember, mean consumption, our continuous variable scale variable, that's our dependent variable in this case. And these 2 categorical variables, presence of another player, known as anonymity, and information about the resource value, or what I've called information. These are our 2 independent variables, so we're going to put those in the fixed factors box. Okay, I'm going to select a few other things whilst we're here. If we click on options, we can ask for descriptives, estimates of effect size, and it's an independent groups design, so we'll ask for Levene's test, homogeneity of tests. Okay, if I click continue, a couple of other things we're going to do. We are going to we're going to click on this EM means button, estimated marginal means. We saw this previously. What this will do is gives us a couple of things. It can, if we move these over, it will give us descriptive statistics for all of our variables, our 2 independent variables and the interaction. But we can also ask it to do post hoc tests on the main effects. So if we click on compare main effects and then select this Bonferroni, I'm going to ask for a Bonferroni adjustment. Okay, so if we get a significant main effect, we can look at Bonferroni adjusted pairwise comparisons. Okay, to compare those means, and that's kind of, we certainly would like that for at least one of our independent variables, the anonymity one, sorry, the information one, because that has more than 2 levels. Okay. Click continue, and the last thing I'm going to ask for are plots. I'm going to ask for 3 plots. I'm going to move anonymity over to the horizontal axis, click add, so that will give me a plot for the main effect of anonymity. Information, move that over to the horizontal axis, click add, it brings it down here to shows us the plots, and that's another one for the plot for the main effect of the information variable, those 3 levels of information. And then we're going to ask for an interaction plot. And it's the best way to do it is whichever of your variables has the most levels. So information has 3 levels, known value, low uncertainty, high uncertainty. If you put that on the horizontal axis, and then the anonymity has two levels, 2 conditions, seen and unseen. If we use that as separate lines, that'll give us a nice interaction plot where we've got 2 lines and we'll be able to see if they cross over or not. So if I click continue, and we could what we could normally do is just click OK and run this analysis, but we're not going to do that. Remember, we opened that syntax box previously. So what we're going to do is we're going to just click this paste button here, like that. And if we go back and look at our syntax editor, you can see what it has done is it's posted the SPSS syntax for this analysis, the whole setup for that analysis that with the steps we've just selected, into the syntax editor. And we're going to make a couple of adjustments. So if we look at this line here, line 10, this is showing us the estimated marginal means is going tables for the interaction anonymity times information. But what we're going to do is we're going to make a couple of changes here, and that will give us the simple effects and necessary post hocs that those simple effects might require with just a couple of lines of code. So all I'm going to do is start typing compare, and SPSS being very nice, easy to use software, gives me a prompt straight away as soon as I start typing. If I click on compare, it will populate that for me. Without putting a space, I'm then going to open some parentheses, and I'm going to put anonymity, the name of one of our independent variables, in parentheses. Close the parentheses there. Okay. And then I'm going to put space, and I'm going to start to type adjust, AD. And again, SPSS prompts us, offers us some options. Without putting a space, I'm going to put parentheses, and the adjustment I want is going to be Bonferroni. So I'm going to select Bonferroni there. Okay. So all I've done in this line here is I've taken the interaction that we asked for in our estimated marginal means tables, anonymity times information, and I've asked it to do some extra comparisons where it's going to hold anonymity constant and compare each level of the other independent variable. Okay, right, so to save me typing, what I'm going to do is highlight that line that I've just typed and Control C to copy it, and then I'm going to, no, I don't want that, sorry, and then I'm going to hit return and create a new line underneath, and then I'm going to paste it in, paste that particular, let me remove the space at the beginning. I'm going to paste the same line below, and I'm just going to make one change. I'm going to change anonymity to the name of the other independent variable, which is information. Okay, so it's when you're typing this, it's important to make sure you type it exactly the same way as your variables are named. So I've got a capital letter at the beginning of each variable name here. So if it's slightly different, then you spell it slightly differently, you won't get the results you are hoping for. All right, so all I've done here is I've added a couple of words really and some brackets to the syntax for the interaction, and I've asked it in one case to hold one of the variables, one of the independent variables constant, information say, and then compare anonymity, compare the different levels of anonymity at each level of the information independent variable, and using a Bonferroni adjustment. And then likewise on the other one, to hold anonymity constant, and then for each level of anonymity, compare information. So for the scene condition, compare all three levels of information using a Bonferroni adjustment to correct for potential type 1 error from pairwise comparisons. Once we've done that, to run this, if you click on run and run all, what we should get is an awful lot of output. Okay, nothing to be scared about though. It's the usual sort of stuff we get. We get a table of descriptives. Here we've got descriptives split by the anonymity variables, seen and unseen, and broken down for each level of the information variable. Okay. The next thing we have, which is the first thing we really would like to look at, is the Levene's test. So we ask for homogeneity variance tests. We want to meet that assumption really. If we can, we want the variances to be equal for around the means of each of our groups. If we can assume that they are, then we're kind of on safe ground really with our parametric statistical test. In this case, we're going to interpret this. It gives us this nice Levene's test. It gives us 4 F ratios, in fact. We're going to use based on the mean, as we've done previously. Gives us a Levene statistic of 0.702 and a significance value of 0.625. So it's not statistically significant. So we can breathe a sigh of relief that because that Levene's test isn't statistically significant, we can assume equal variances between the groups that we're comparing. And that's a good thing. So we can safely now move on and look at our ANOVA summary table. Okay, and that's this test between subjects effects. And as you know from other factorial ANOVA stuff we've talked about, it gives you 3 different F ratios for a two-way ANOVA that you're interested in. One for the main effect of your first independent variable, one for the main effect of your second independent variable, and one for the interaction between your 2 independent variables. So here we can see anonymity is our first independent variable. And remember, that's the seen and unseen, 2 levels to that. And we can see we've got an F ratio of 15.58 and a p-value is p is less than 0.001. So we've got a statistically significant p-value. Okay, all right, so we've got a significant F ratio there, significant main effect of anonymity. Then our second independent variable, information, do we have a significant main effect of information? Well, this time we've got an F value of 6.041. P is equal to 0.005. So yes, we also have a significant main effect of information. Okay, but this is the key thing, remember. Do we have a significant interaction? And we look at this anonymity times information line here. And we see we've got an F value of 8.507. P is less than 0.001. So yes, we have a significant interaction. So these results are suggesting we have a significant main effect of anonymity, a significant main effect of information, and a significant interaction between the two. What that means really is the first thing we should really concentrate on is the interaction, because the significance of the main effects may be just due to the interaction. The interaction is actually telling us that although the main effects are significant, they're probably not consistent, and there's probably something happening, something different happening at one level of one independent variable as a result of the other independent variable. Okay, but I will break with the sensible thing to do, the convention of examining the interaction first. And what I'll do is we will look at the main effects first, and then we'll go on and tease apart the interaction to see what's going on. Okay, so we know we've got a significant main effect of anonymity, and we know that that's a variable with 2 levels. So in this case, the conditions are seen and unseen. So we could report the F value, a significant main effect of anonymity, or seen F value of this, significance level this. And to understand what's going on there, because we've only got 2 levels, there's nothing further we really need to do than look at the descriptives, look at the means for these estimated marginal means we ask for the seen and unseen condition in this table here. You see the seen condition, the mean consumption decision was 5, and in the unseen condition, mean consumption is 6.333. Okay, so we can say from that consumption, if this main effect is consistent, it's not going to be, but if it was, that consumption is significantly higher in the unseen condition than the seen condition. Okay, so the second main effect we had there was information, and that's statistically significant. And the information is a variable with 3 levels. Okay, so we've got certain known value, low uncertainty, high uncertainty. Okay, in terms of how much the players know about the resource that's available. So because we've got 3 levels, we'd really need to do post hoc tests to find out where the significant differences are between these 3 levels. So luckily, if you look here, it's labelled it as number 2, information about resource value for us. And as we've done previously, it gives us a table of means, estimated marginal means there. shows us, we can see from that table, the known value mean is 4.938, low uncertainty 5.688, high uncertainty 6.375. And in order to interpret whether these differences are significant between the three means, we can look at this pairwise comparisons table. We've done this previously, and all it does is involve comparing each level with every other level. So if we compare the known value level with the low uncertainty level, we can see the significance level is 0.231. So not statistically significant difference between known and low. The known value and the high uncertainty level is a significance value of 0.004. So a statistically significant difference between known and high uncertainty. And then lastly, what about low uncertainty and high uncertainty? We get a p-value of 0.312, so not statistically significant difference. So the only significant difference is between the lowest and the highest mean. That's the known and the high uncertainty condition. So those were our two main effects really, and we could scroll down and have a look at the main effects plots that we got. So what we got was, so this was for the first IV for anonymity, we got a significant difference, and this plot confirms that the unseen condition was significantly higher than the seen condition. And this plot, it represents what we've just looked at on that pairwise comparisons table. But what we know now is that the known value mean is significantly different to the high uncertainty mean, but known value and low uncertainty are not significantly different, and low uncertainty and high uncertainty are not significantly different. But the problem here is, as we know, we've got a significant interaction. So knowing this, it's not likely to be a general trend. It looks like we've got a general trend there, but if we look at our interaction graph, it tells us a different story. So although we might report a significant main effect was found for anonymity, a significant main effect was found for information, these were not consistent due to a significant interaction between the two variables. And that is why that is where we really need to do the work, and that means focusing on this interaction plot. So this is what it looks like, and you can see from looking at it, so we've got on the x-axis there, we've got the three levels of the information variable, known, low, and high, and the different colored lines represent the different levels of the anonymity variable. So the blue line there shows the different mean scores in the seen condition for the known, low, and high uncertainty groups, and the green line shows the unseen condition difference in means between the known, low, and high uncertainty groups. Okay, so having already stated, looking at this tells us we've got a significant interaction. Looking at our ANOVA summary table, if we go all the way back up, where are you? There we go. We already know here we've got a significant interaction. F is 8.507, P is less than 0.001. What we need to do now is a series of we've inspected the interaction plot. We need to do a series of simple effects tests, really, to tease this apart. Now, it really means 5 different comparisons that we're doing. And what we're going to do is, firstly, we're going to hold each level of information constant and compare the two groups of the other information, independent variable. So we're going to just look at known value condition for information, and we're going to compare the seen with the unseen group, okay? And then we're going to just look at low uncertainty, and we're going to compare these two means, the seen with the unseen group. And then we're just going to look at high uncertainty, and we're going to compare the unseen with the seen. Again, so comparing these 2 points. So 3 comparisons. We could do 3 t-tests with a Bonferroni adjustment, but we've already got SPSS to give us the answer to this, and what it's done is Bonferroni adjusted F tests, ANOVA tests for us, one-way ANOVAs, but just comparing 2 means. Okay, so let's have a look at those three comparisons then. And what we need to do is scroll back up and find it in this huge amount of information we've got. And quite conveniently, and it's in the correct order, it's given us this section 3 here, presence of other player times information about the resource. And if we scroll down, if we look at this univariate test table, what we have here are three ANOVA results. One for known value, one for low uncertainty, and one for high uncertainty. So these are the three comparisons. So basically what each of these F values relates to is a comparison between the seen and unseen group for just the known value condition, then seen and unseen group, just the low uncertainty condition, seen and unseen group, and the high uncertainty condition. So what we can see here is for the known value condition of information, the F ratio is 24.150, P is less than 0.001. So we've got a statistically significant difference between the seen and unseen condition in the known value condition of information. If we look at our low uncertainty, then the F ratio is 7.715, P is equal to 0.008. So again, we've got a statistically significant difference between the seen and the unseen condition in the low uncertainty level of the information variable. High uncertainty, we've got an F value of 0.73 and P is equal to 0.398, so it's not statistically significantly different. So what we've seen here is with these three F values that the unseen condition is significantly higher than the seen condition in the known value level. The unseen condition is significantly higher than the seen condition in the low uncertainty level, but there is not a significant difference between the seen and unseen condition when uncertainty is high. Okay, so that's three of the comparisons. And because we're only comparing two levels, if we go back up to section 3, because we're only comparing two levels, we could report those F values and then we can look at our table of means here. And what we would do is we'd look at known value for the seen condition, got a mean of 3.5, known value for the unseen condition, got a mean of 6.375. So that's our first comparison. Low uncertainty for the seen condition, got a mean of 4.875. Low uncertainty and the unseen condition, a mean of 6.50. So we pick those means out and say which ones are higher, which ones are lower. We know which is the case just from looking at the plot, essentially. Okay, so that's 3 of our 5 comparisons to unpick this interaction. The other ones we need to do is we need to then hold anonymity, that information, presence of the other player variable, constant, and look at if there are differences between the 3 levels of information. Okay, so what that means is effectively taking the points on this blue line for the seen condition and doing a one-way ANOVA to compare those 3 points. So in the seen condition, is there a significant difference between the known value, the low uncertainty, and the high uncertainty means? And then just taking the green line for the unseen condition, comparing those 3 points. Is there a difference between the known value unseen and the low uncertainty in the unseen condition and the high uncertainty in the unseen condition? So 2 one-way ANOVAs. And because we did that little bit of typing, use the syntax editor, okay, we have it's under section 4, presence of all the players and info about resource value. We have this table with a couple of F values in it, one for seen, one for unseen. And what that is giving us essentially is each of those 2 ANOVAs. So for the seen condition, we can see we've got an F value of 14.335, P is less than 0.001. Okay, so we've got a statistically significant difference between the three means in the seen condition. Okay, for the unseen condition though, we've got an F value of 0.213 and P is equal to 0.809, so not a statistically significant difference. So we can ignore the unseen condition because there are no significant differences. But we have differences in the seen condition, and we've got three levels, three groups that we're comparing: known, low uncertainty, and high uncertainty. So we would then need to do some follow-on post-hoc tests to see which of those were significantly different. So if we pop back in, before we do that, if we pop back and look at the plot here, what we've found is a significant difference between these three blue means. And the only thing we can say from the ANOVA is that the lowest and the highest will be significantly different from each other. We don't know if known and low will be significantly different, or low and high will be statistically significantly different. We need to do some post-hocs to test that. We also know that the unseen condition, there wasn't a statistically significant difference between any of these three data points, and I guess we could have assumed that to be the case because it's almost a flat line. These are almost the same mean score. The low and known value, I mean, high uncertainty is slightly lower than the other two, but it's not going to be statistically significantly lower. They're all between about 6 and 6.5. In terms of mean consumption. Okay, so last thing to do then is, given that we've got a significant simple effect for the seen condition, is to just kind of look to see where which of these three means are different. Okay, so if we go back up there, we've got this was the F table we used, and we can look at this pairwise comparisons table, and we can completely ignore the bottom half, the unseen, and what we've got is, if we just look at the seen condition, we've got our usual pairwise comparisons. So known value with low, known value with high, low with high to make, but this time the table has been split further into the seen and the unseen. We're only interested in seen because that's the only one that was significant. Okay, so what we will find is if we compare known with low uncertainty, we have a significance value of 0.071, so not statistically significantly different. Known and high uncertainty, these were the two highest and lowest means. They are statistically significantly different. We could have guessed that. So their P level is less than 0.001. And the last comparison we need to make is low uncertainty with high uncertainty. And we get a p-value, a significance level of 0.014. So those two are statistically significantly different as well. So what we found is, looking at the blue line, known value and low uncertainty are not statistically significantly different. Known value and high uncertainty are statistically significantly different, and low uncertainty and high uncertainty are statistically significantly different. So the conclusions that we can draw from this, as I said before, when we've got a disorderly significant interaction of this type, what's happening in terms of scores depends on what level of the other variable you're looking at. So in the unseen condition, mean consumption decisions are significantly higher than the seen condition, but only in the known and low uncertainty conditions of the information independent variable. So when there's high uncertainty, there is no significant difference in mean consumption between the seen and unseen conditions. Okay, so this has taken a while to explain because picking apart factorial designs with significant interactions can be quite complex, but those are the things we would conclude. We'd say the significantly higher mean consumption in the unseen condition, but it depends on the other independent variable, and that significant difference disappears when both conditions are exposed to high uncertainty. All right, I've talked for too long. Hopefully this was helpful, and I shall speak to you soon.